Welcome to Lesson 2, and in this lesson we start with the basics of the Swift programming language. I'm going to provide you with a playgrounds file for each one of these lessons or parts of the lesson, and I'd like you to load that onto your Mac computer. And if you have a look at the playgrounds file, you will see a whole lot of statements. They're in nice big bold writing. But before each statement, I give you an explanation of that statement in green using comments. So if you want to know what each statement does, read the comments before each statement. And I tried to keep each playgrounds file quite simple with a few concepts, thus not complicating things in each part of these lessons. So we tackle a few concepts and we build on those concepts. The best way to view these lessons is to load the playgrounds file that I give you onto your Mac, and then on a second screen, preferably an iPad, open up the iTunes U course and then watch the video. And as you're watching my videos on your iPad screen or second screen, you then follow on your Mac on the playgrounds file. And then you're welcome to interact with the playgrounds file by changing some of the values, experimenting, trying to introduce some errors, see what errors the compiler is throwing up, and just interactively engage with the lesson rather than just watching the video without doing anything on the computer. So my suggestion is, while you're watching the video, you then pause the video and then try out some new statements on the playgrounds file that I sent to you. So let's get stuck into it. The first statement is import UI kit. That is required in all playgrounds file. I'll talk about this in later chapters, why we need that. But for now, just type it in. Okay, so let's get to our first statement in Swift. This is our first statement. Okay, this is called a declaration. Now, what do I mean by declaration? Here you are stating that some identifier or name, in this case num1, is equal to some value. In this case, it's 12. And you'll notice that there's a keyword here called var. Var stands for variable. It means that this identifier num1 is a variable. Its value can change. Now, I've put in an initial value of 12, but it can change during the course of the program. That's why we call it a variable. So num1 is a variable. Now notice next to num1, we also have a keyword there called int. This is the type of num1. We say this is the type. Int stands for integer, short form for integer. And you know from mathematics, integers are whole numbers. They can be positive, they can be negative, or they can be zero. But they have no decimal points. They have no fractional part to it. So I'm saying to the computer, declare me a variable called num1, and its type is going to be integer, which means I cannot put in any other number that's not an integer into this variable. Okay. So how does the type help the computer? Well, one of the reasons why we need to specify the type of a variable is that the computer uses the type of the variable to allocate the correct amount of storage space in RAM. You know that RAM stores all of our variables, and it uses bits and bytes, or binary, to store these variables. By defining the type, the computer knows how much of memory it needs to allocate to this variable. Another reason is, by defining the type, we prevent errors. We only allow certain operations on that variable and not other operations which are illegal. And this prevents a lot of errors from happening to our types. So that was our first statement. Okay. Now, this is our second statement. Here I'm defining another variable, and the name of the variable is num2, but this variable is of type double. This means that this variable can take real numbers, and real numbers are numbers that have got a decimal points. It's a whole number plus some fractional part or decimal points after the whole number. And here you see I'm putting the number 42.76, which is a real number, into num2, and I'm defining that this num2 is of type double or real number. In Swift, we have a number of data types, and I'm going to take you through some of the more common data types that we use, and I'm going to show you a picture which I'll give to you in the iTunes U course as well, and you can take a look at that and keep that for your reference. So I'm going to show you now some of the other data types that we use besides int and double. Okay, so here's a list. One of the data types is called bool. Bool stands for Boolean or binary. And bool can only take two values, true or false. Or another way of thinking about it, true being 1 and false being 0, binary or Boolean. Then we have several integer data types. We have int 32, int 64, int 16, and int 8. These are integers, whole numbers, which are positive, negative, or 0. But some integers are quite big, like 100,045, and some integers are quite small, like the number 3 or -11. So the computer, depending on the size of the integer, uses a certain number of bits to store it in RAM. So the 32 here means 32 bits, 64 bits, the 8 here means 8 bits, and the 16 here means 16 bits. So depending on the size of the integer, the computer would use different number of bits to store these integers. There's another type of integer called uint or unsigned integer. Now these are similar to normal integers, except they don't allow you to put in negative numbers. So you're only allowed to put in 0 and positive numbers, 1, 2, 3, 4. You're not allowed to put in -8 or -16. These are called unsigned integers, UINT, of different sizes. Then we get to real numbers, the ones with the whole number part and fractional or decimal points after it. We have two of them. We have float and we have double. If you've got a small real number, like 324.147, that's considered a small real number, then you would use the float data type. But if you have a large real number with lots of decimal points, then you would use the type called double. Then we have a data type called character. These are letters of the alphabet like A, B, C, and D. You can also put in numbers 0, 1, 2, 3, or you can put in special characters or symbols like question mark, apostrophe, comma, asterisk. So, strings are a combination of letters, and you normally use this for words or sentences. Now there are quite a few data types here. Which are the ones we are going to use most often? We will use bool, we'll use int, int. Don't worry too much about the uint, we won't use too much of that. We'll be using double, we'll use character, and we will use string. So that's the different data types that you'd find in Swift. There are more data types as well, and in future lessons I'll show you how to define your own data types, your custom built data types. So let's get back to our playgrounds file where we last left off. We were down here. Okay. Num1 is 12. Since num1 is a variable, I can put in a new value into it. So that's what I'm doing here. I'm placing the value of 20 into num1. So num1's new value is 20. Here I'm defining a new variable called num3 of type integer, and I'm putting the value of 100 into it. Yeah. The next statement, I'm taking the value of num3, which is 100, and placing that into num1. That means I'm replacing the value of num1 with num3. Now the way we read this statement, we don't read it from left to right. We read it from right to left. This means that I'm taking the value which is sitting in num3, which is 100, and placing it into num1. And the new value of num1 is 100. Okay. So what have we done so far? We've defined a variable called num1, which is an integer. We've defined a variable called num2, which is double. And we defined a variable called num3, which is also an integer. Now let's see what happens if I do something like this. Num1 equals to num2. Okay. So I'm trying to take the value of num2 and place it into num1. Okay. Do you think that will work? No, it won't work. How do I know it's not going to work? Because the playground's compiler throws up an error, and you notice on the left hand side here it's showing me a red circle. That means that it's not accepting this statement. Click on it, and why is it not accepting this statement? It says that you cannot assign a value of type double to a value of type int. Yes, so num2 is double. It is 42.76. The computer is having difficulty taking 42.76 and placing it into num1 because num1 was defined as an integer, and num1 can only hold integers. So the computer is having a problem trying to assign a double number to an integer number, and it cannot fit because there's just not enough memory space to accept that number. So that's why this statement will not work. Let me delete it. But there is a trick that you could pull. You first need to convert num2 into an integer. Yeah. So you take the num2, which is 42.76, remove the decimal part, the fractional part, and convert it to just the whole number part, which is 42. Right? So that's what you're doing here. You're saying to the computer, take the number 2 and convert it to an integer, and then take that new integer that you've got, 42, and then place it into num1. So if you want to mix data types and your computer is throwing up an error, please make sure that you convert the one data type to another data type. And this is called casting. Casting here. Let's move along. We spoke about variables whose values can change, but there are also constants whose values cannot change. Once you give them an initial value, you cannot now change their value. And we use the keyword let to handle constants. Now here I'm defining an identifier called pi value, which is a double, and I'm assigning it the value of 3.14. Now you know in mathematics, pi is 3.14, and that will never change. So if you try to put in a new value for pi, it shouldn't allow you to do this. So that's what I'm doing here. I'm defining a value called pi value, which is double. It's a real number. Putting the value of 3.14, and to tell the compiler or computer that it is a constant, I'm putting the keyword let. Right. Now let's test. let's try and change the value of pi value. Let's put in a new value. Let's put 4.78. I'm trying to change the value of pi, which is mathematically impossible. Right? You'll notice that the compiler throws up an error. Top left, left-hand corner, red circle. Let's click on it. It says cannot assign to let value pi value. That's because pi value was defined as a constant and you cannot change constants. Now I'm defining, let's take another example of how I'll define a constant. I'm defining a constant called Earth's gravity in meters per second. You know, in physics that Earth's gravity is roughly 10 meters per second squared, and that value for all purposes remains constant, right? It's constant average value. So I'm defining a variable called Earth gravity in meters per second. It is double, yeah, and I'm giving it the value of 10.01, and it's a constant. Identifiers can be quite long as you want them to be, but make sure that when you type in an identifier, you always start with a small letter. Okay, notice here as well, pi value is small letter, num1 is small letter. Capital letters are normally reserved when we define classes later on, but any variables or constants that you declare, try and start off with a small letter. Now you'll also notice that since this is a long sentence, a long word, you notice I start off with a small letter, and when I start off with the next word, I put a capital letter, next word, capital letter, and so on. This is called camel case convention in Swift. It's like the humps of a camel, where it goes low and then goes up again and down and up again. This is called camel case or humps naming convention. So I hope you enjoyed this part of the lesson, where we dealt with declarations, variables, constants, the different types of data types, and also how to do casting, where you'd convert one data type to the next data type. So I'll see you in the next part of this lesson.